one of the most recognizable locomotives on the modern British railway network, the Class 60 is a machine that proved to be the last British-built diesel freight engine in history, rounding out a near 200-year legacy by providing one of the strongest designs to ever operate on the main line. However, no more than a decade after its introduction, most Class 60s found themselves laid up in long-term storage at depots across the UK, as the primary freight operator of the nation opted to standardise its fleet with the Canadian-built Class 66, putting these nearly new but severely flawed machines out of work. During the early 1980s, British Rail found itself increasingly under pressure to reform and modernise, with the British government, under the prevailing ethos of free market economics, beginning to steer national industries, including the railways, towards a future shaped by privatisation and deregulation, while within British Rail itself, there was a growing recognition that long-standing operational methods and inherited management structures were becoming outdated and unsustainable in the face of rising competition and changing commercial expectation. Efficiency and reliability, once considered desirable, were now fast becoming essential as private sector companies began to encroach upon areas that had traditionally been the preserve of state-owned operations, with the heart of the challenge being the inadequacy of its existing fleet of heavy freight locomotives, particularly those classified as Type 5 diesel-electric engines intended for the most demanding freight duties. The Class 56, which had entered service during the mid-1970s, soon earned a reputation for unreliability, this being especially true of the first 30 examples, which had been constructed under license in Romania by Electroputere, and were plagued with construction flaws and poor quality assembly that resulted in performance that fell well below expectations, with the situation requiring British engineers to carry out extensive remedial work to bring these locomotives up to a basic operational standard, incurring considerable cost and disruption in the process. To improve upon the shortcomings of the Class 56, British Rail introduced the Class 58 in the early 1980s, which was a modular design built at Doncaster Works and intended to simplify maintenance and reduce operating costs. But despite being more advanced in construction and generally more reliable than its predecessor, the Class 58 still failed to meet the increasingly demanding requirements of the freight market. Therefore, it became apparent that even the most modern of British Rail's domestic locomotives struggled to deliver the high availability and consistent haulage performance now expected, particularly by customers in industries such as construction and aggregates, with this dissatisfaction coming to a head when Foster Yeoman, one of the UK's leading quarrying and aggregate companies, took the radical step of bypassing British Rail entirely. Frustrated by frequent delays and breakdowns caused by BR's aging and unreliable locomotive stock, the company sought a solution independently and turned to the global market, and in a move that shocked many within the UK rail industry, Foster Yeoman placed an order with General Motors' Electromotive division in the United States, with the result being the Class 59, a locomotive based on the American SD40-2, adapted for operation in Britain. Delivered in 1986, these locomotives proved revolutionary, with a modular design, robust components, and proven mechanical systems, allowing the Class 59 to achieve extraordinary levels of performance and reliability, with availability rates consistently exceeding 95%, a dramatic contrast to the British-built equivalents, and one that immediately exposed the shortcomings of the domestic locomotive industry. The remarkable success of the Class 59 posed an existential threat to British Rail's freight operations, as for the first time, a private operator had successfully demonstrated that it could procure and run its own locomotives more efficiently than the national provider, with this shift raising serious concerns within British Rail's upper management and the Department for Transport. With there now being a clear and present risk that other major freight users might follow Foster Yeoman's example and begin to contract their own motive power from abroad, further diminishing BR's relevance in the increasingly competitive rail freight sector, the company was constrained by political and industrial considerations, as ordering large numbers of foreign-built locomotives risked provoking strong opposition from trade unions and manufacturers, who would see such a move as a betrayal of the domestic rail industry. Faced with this dilemma, British Rail instead turned its focus towards developing a new heavy freight locomotive that would be designed and built in Britain using British components wherever possible, with this initiative being intended not only to address the technological gap between BR and its foreign competitors, but also to demonstrate that British engineering could still produce a modern and effective locomotive capable of meeting the needs of contemporary freight operations. The first attempt at this new direction came in the form of the proposed Class 38, a concept intended to replace a wide range of older diesel traction, and as part of this program, new engines from Merley's Blackstone and Ruston were trialled in modified Class 37s to assess their suitability for future locomotives, with these experimental conversions being used to evaluate fuel efficiency, emissions, and maintenance requirements under real operating conditions. Despite early enthusiasm, the Class 38 project was ultimately scrapped, as changing priorities within government, which increasingly viewed wagon load and short-distance freight services such as Speedlink as uneconomical, led to the withdrawal of funding, with the focus shifting towards bulk, long-distance freight traffic, particularly coal, steel, and aggregates, which meant that investment would only be forthcoming for traction suitable for this work. With the Class 38 shelved, British Rail narrowed its focus even further, and it became evident that any new locomotive would have to be tailored exclusively for block trains and heavy-haul operations, with a formal specification being drawn up for a new Type 5 freight locomotive that would embody the lessons of previous failures while incorporating the reliability and power demonstrated by the American-built Class 59. The specification demanded a locomotive capable of delivering high continuous tractive effort, equipped with state-of-the-art systems to improve adhesion and minimize wheel slip, with one of the key technological requirements being the inclusion of a microprocessor-controlled wheel creep system, a feature that allowed the locomotive to maintain optimal traction even under adverse track conditions such as wet or greasy rails, allowing the new locomotive to deliver consistent haulage performance without requiring double heading or banking assistance on heavy gradients. On August 10, 1987, British Rail formally launched an invitation to tender for a fleet of 100 new diesel-electric locomotives, with the new locomotives being required to meet a challenging and unprecedented set of performance criteria, most notably the stipulation of a 95% availability rate, far higher than anything achieved by existing British-built diesel traction. By the close of the bidding period in November 1987, just 3 companies had submitted formal responses, the first being Metro Camel, but their proposal was based on a concept that lacked technical maturity and ultimately failed to meet the performance guarantees required under the terms of the tender, with Metro Camel being experienced in diesel multiple unit construction and other passenger vehicles, but they lacked experience with mainline heavy freight locomotives. The second bid came from the General Electric Company, which proposed a design developed in partnership with General Motors' Electromotive division, this being effectively a domestically assembled version of the Class 59. But while it offered a proven platform and excellent reliability figures, the proposal was dismissed for its lack of originality and over-reliance on imported technology. The third and ultimately successful bid came from Brush Traction based in Loughborough, with Brush presenting a completely new locomotive concept, drawing upon in-house design expertise, and a partnership with Merley's Blackstone and Ruston for the power units, with the Brush design incorporating a choice between 2 prime movers, one from Merley's and the other from Ruston. Of particular interest was the inclusion of separately excited or SEPEX traction control, a more advanced form of electrical traction management that had been previously trialled in a single Class 58 locomotive, with this system offering improved control under low adhesion conditions and reduced the risk of wheel slip, critical features for locomotives expected to haul heavy bulk trains across gradients and variable track conditions. Following detailed evaluation, Brush's proposal was chosen as the most technically and economically viable, with the Ruston engine option being later discarded after it failed to meet new emissions standards, leaving the Merley's Blackstone 8MB275T as the definitive power unit for the class. On May 17, 1988, Paul Channon, Secretary of State for Transport, announced a landmark £120 million order for 100 locomotives to be built by Brush, with the contract stipulating that the first example be delivered within a year, and included strong financial incentives to ensure the finished product met stringent availability and performance targets. Designated Class 60, the new locomotive would embody the latest advanced engineering principles available in British diesel traction at the time, employing a co-co wheel configuration, distributing its substantial weight across 6 powered axles to maximize traction and minimize rail wear, and with a top speed of 60 miles an hour, it was designed for heavy freight rather than high-speed operations, making it ideal for bulk haulage in the coal, steel, aggregates, and petroleum sectors. The heart of the Class 60 was the Merley's Blackstone engine, with this 8-cylinder inline 4-stroke diesel engine having a bore of 275mm and a stroke of 305mm, displacing 145 litres in total and being rated at 3,100 horsepower, making it among the most fuel-efficient engines available at the time, with a specific fuel consumption of around 189 grams per kilowatt-hour. Although relatively heavy, The engine's low cylinder count for its power class was intended to lower overall maintenance demands and reduce long-term operational costs, with this same engine design having also seen use in marine applications, lending additional confidence to its robustness. Power from the prime mover was transmitted via a Brush BA1006A main alternator, which converted mechanical energy into electricity for the traction system, with each of the 6 axles being driven by a Brush TM2161A DC traction motor mounted nose suspended and axle hung, and controlled individually through SEPEX microprocessor-based power supplies, with this system allowing for precise modulation of torque on each axle, reducing the likelihood of wheel slip and enabling superior traction even under poor adhesion conditions. Supporting systems were powered by a secondary Brush BAA702A auxiliary alternator, which provided electrical power for vital subsystems, including radiator fans, lubrication pumps, fuel oil circulation, traction motor blowers, and the onboard air compressor, with both alternators being driven directly from the main engine, ensuring continuous operation as long as the prime mover was running. The Class 60's bodywork was fabricated using a monocoque structure with diagonal trusses, designed to absorb structural stresses through the outer shell rather than relying on a deep underframe, with this method allowing for a lighter, stiffer body that required less internal reinforcement and increased space for internal components, with the body shells being built by Procore of Wakefield and delivered fully painted to Brush's Loughborough works for final assembly, while cooler groups and other key modules were subcontracted to specialist manufacturers and electrical and control systems were supplied by the Hawker Siddeley Group. The first of the new locomotives, 60001 Steadfast, emerged from Brush Traction's Loughborough works in June 1989, marking the beginning of what was intended to be a transformative chapter in British Rail's freight operations, with the handover to British Rail being accompanied by a formal ceremony, with 60001, after its debut, being sent directly to the Railway Technical Centre in Derby for an intensive programme of testing. It was here, however, that the locomotive's shortcomings began to emerge, with the trials quickly uncovering a substantial list of faults, particularly with the locomotive's advanced microprocessor-based wheel creep control system, a critical component that governed adhesion under load, while the suspension system also proved problematic, requiring significant revision. The issues were not minor teething problems, but fundamental design and integration flaws which necessitated extensive modification, and as a result, the process of bringing the locomotive up to operational standard proved far more protracted than originally envisaged, and instead of entering traffic within the expected time frame, 60001 remained sidelined as Brush engineers worked alongside BR technical staff to diagnose and correct the defect. This program of redesign and rectification continued well into the following year, with the locomotive not finally accepted into traffic until September 1990, 16 months after the initial rollout, all while production of the rest of the Class 60 fleet continued regardless, and dozens of additional units were completed and delivered to BR depots. However, despite British Rail having received approximately 40 locomotives by this point, few were operational, with the vast majority remaining idle, either awaiting acceptance or returning to the manufacturer for rework, with the backlog of non-functional locomotives causing growing concern within British Rail's management. At the height of the crisis, discussions reportedly took place regarding the possible cancellation of the remaining 60 locomotives in the order, and the project appeared to be teetering on the brink of collapse, potentially catastrophic outcome given the scale of the financial investment involved. Nevertheless, British Rail ultimately persevered, opting to proceed with the full batch of 100 locomotives, but even so, the technical difficulties left a lasting legacy, as by the time the fleet had been completed, it was estimated that there were approximately 10,000 warranty faults spread across the locomotives, an astonishing figure that worked out to an average of 100 faults per unit, a stark contrast to the relatively smooth and trouble-free introduction of the Class 59. Despite these early challenges, operational deployment did finally begin, and in October 1990, locomotives 60017 and 018 became the first Class 60s to enter revenue-earning service, with their arrival marking the start of what British Rail hoped would be a new era of powerful, high-traction locomotives capable of handling the heaviest block freight movements across the network. By the end of that year, 12 locomotives had entered traffic, with more following throughout 1991 and into 1992, as modifications were completed and acceptance testing progressed, with the Class 60s having originally been intended for clearly defined roles within British Rail's trainload freight business sectors, and allocations were carefully planned with 35 locomotives being earmarked for coal duties, 25 for the construction sector, 22 for metals traffic, and 18 for petroleum services, as reflected in the sector decals applied to each locomotive during production. However, the long delays in commissioning meant that many of these allocations were rendered moot by the time the locomotives entered traffic, and in many cases, the engines ended up working in sectors different from those originally intended, leading to a degree of visual confusion on the network, as locomotives frequently bore decals that no longer corresponded to their operational roles. By May 1992, the penultimate locomotive, 60095 Crib Goch, had joined the fleet, and less than a year later, in March 1993, the final member of the class, 6100 Boar of Badenoch, was accepted into traffic, bringing an end to a fraught but ultimately completed production cycle. Once in regular service, the Class 60s began to prove their worth in heavy freight applications, with their exceptional tractive effort, combined with sophisticated traction control, making them ideal for hauling long, fully loaded trains, thus allowing them to rapidly displace older traction, including double-headed Class 33s on aggregate trains, Class 20s on coal workings, and Class 31s and 73s on petroleum and general duties. Despite their mechanical prowess, however, the issue of reliability lingered well into their early years of operation, as even with the fleet beginning to make its mark on heavy freight corridors, a significant number of locomotives remained out of action at any given time, and it was not uncommon for as many as 10% of the fleet to be back at brush for rectification or undergoing repairs at British Rail depots, while others were parked up awaiting parts or subject to rolling modifications. In practice, this meant that the real-world availability of the Class 60s fell far short of the ambitious 95% target that had been set during the planning stages, and on average, a Class 60 could only be expected to provide around 1,000 hours of actual work per year, an underwhelming figure considering the high expectations and cost. In 1994, as British Rail moved closer to full privatisation, its freight operations were divided among 3 newly created shadow franchises intended to mirror the future commercial structure of the rail industry, with the Class 60s being distributed among these new operators, with mainline freight receiving the largest allocation with 52 locomotives, followed by load haul with 31 and Transrail with 17. Although this restructuring represented a major shift in operational control, it brought few immediate visual changes to the locomotives themselves, with the vast majority of the Class 60s remaining in their original rail freight triple grey liveries, while only a small number were given an entirely new colour scheme, 5 locomotives receiving load haul's distinctive black and orange livery, while just 3 were repainted into the blue of mainline freight. The process of privatisation concluded in 1995, when the 3 freight companies were purchased by North and South Railways, a subsidiary of the American-owned Wisconsin Central Transportation Corporation, with this newly formed entity being soon rebranded as English, Welsh and Scottish Railways, more commonly known as EWS, and under this new ownership, the Class 60 fleet was once again unified, returning to centralised management after only a brief period of division. EWS inherited not only the locomotives, but also the operational challenges they presented, as despite technical improvements carried out since their introduction, the Class 60s remained beset by reliability concerns, and thus, by the late 1990s, EWS began to take decisive action to modernise and rationalise its motive power fleet, with many of the locomotives inherited from British Rail, particularly classes 31, 33, 37, 47, 56 and 58, being not only aging, but increasingly uneconomical to maintain. Their declining reliability and non-standard designs made them less suited to a modern, commercially driven freight operation, and thus to replace these, EWS placed a substantial order for 215 new locomotives, originally designated Class 61, but eventually delivered as Class 66. These machines drawing heavily on the proven success of the earlier Class 59s, featuring a modular design, high reliability, and low maintenance requirements. And though they were slightly less powerful than the Class 60, the new locomotives offered greater operational flexibility and consistent availability, making them ideal for a variety of freight tasks. The first Class 66s arrived in 1998 and made an immediate impact, with their trouble-free entry into service and reliable performance quickly shifting EWS's operational strategy, with older locomotive types being withdrawn en masse or placed into storage, and the Class 60 fleet, although still relatively modern, began to see a reduction in use. While the Class 60s were not initially targeted for withdrawal, their higher maintenance costs and lower reliability made them less attractive than the newer imports, and over time, more and more Class 60s were placed into storage, used less frequently, or relegated to secondary duties, despite being more capable in terms of pure tractive effort. In 1999, EWS introduced a revised maintenance and operational regime to streamline its locomotive management, and under this new system, the Class 60s were centrally managed through Towton Depot in Nottinghamshire, with locomotives allocated to a system-wide maintenance pool, thus marking the end of regional allocation practices inherited from the earlier trainload freight model. From this point onwards, the locomotives were moved across the network as required, rather than being tied to specific depots or traffic flows, with 2000 seeing 60001 formally transferred to Thornaby as part of this realignment, reflecting EWS's new emphasis on centralized fleet management and a more efficient deployment. Throughout this transitional period, EWS gradually repainted parts of the Class 60 fleet into its own house colors, with the new livery featuring a distinctive maroon and gold scheme, though given the cost and logistical burden of repainting the entire fleet, many Class 60s continued to operate in the older triple grey rail freight colors well into the 2000s. However, as the Class 66 fleet expanded and took over a growing share of block freight duties, the Class 60s began to suffer from marked underutilization, and by the mid-2000s, this reduction had become significant, reaching as high as 40% of the Class 60 fleet being out of use at one time, being consigned to storage in sidings across the country. The most prominent location for stored examples was Towton Depot, where rows of mothballed Class 60s became a familiar sight, with some having been removed from traffic due to high engine hours or minor faults deemed uneconomical to repair under existing budgetary constraints, while others were stored tactically in anticipation of future traffic that never materialized. Despite their dwindling numbers and the rise of the Class 66, the Class 60s were not entirely sidelined, with a core group remaining in traffic, performing selectively on services that demanded their specific strengths, these including heavy bulk flows such as steel, petroleum, coal, and aggregates. But even within these niches, their numbers continued to shrink as operational economics shifted further in favor of the new locomotives. In 2007, a significant development occurred when Deutsche Bahn, the German state railway company, acquired EWS as part of its expansion into the UK rail freight market, with this acquisition bringing the Class 60s under the banner of DB Schenker, a new identity that promised greater investment and a more strategic approach to freight operation. Though at the time of the takeover, fewer than 15 Class 60s were still in active service, and many within the industry expected the class to be withdrawn entirely. In 2010, DB Schenker investigated whether the class could be returned to productive service, and 2 locomotives were selected for extensive trial modifications, receiving both mechanical and electrical upgrades to test the feasibility of a broader refurbishment strategy. These initial trials produced encouraging results, and the locomotives demonstrated markedly improved reliability and performance, prompting DB Schenker to commit to a more comprehensive refurbishment program, with this initiative, branded the Super 60 program, seeking to breathe new life into the fleet by overhauling 20 additional locomotives. This work was carried out predominantly at Towton, with the Super 60 upgrade involving the stripping of each locomotive down to its fundamental components and rebuilding critical systems such as the engine, traction motors, bogies, control equipment, and cab interiors, with the goal being to extend the working lives of these locomotives by at least 15 years, allowing them to remain in frontline service into the mid-2020s and beyond. Despite the success of the overhaul program, it was not extended to the entire class, with the scale of investment required to modernize all 100 locomotives being deemed unjustifiable in light of changing freight patterns and the increasing dominance of newer locomotives such as the Class 66, and thus a significant portion of the Class 60 fleet remained stored, many of them for over a decade. In an effort to reduce its stock of surplus assets, DB Schenker began offering stored Class 60s for sale in 2012 and 2013, with around 20 units being made available, though these early attempts to find buyers were unsuccessful, largely due to their poor condition and the cost of returning them to service, though in 2014, the situation changed when Collis Rail purchased a batch of 10 locomotives. These units were put through the Super 60 overhaul program prior to being reintroduced to traffic, where they were allocated to heavy freight duties such as bitumen and timber services, with their reliability and performance proving sufficient to maintain their utility for several years, before eventually, in July 2018, all 10 Collis-owned Class 60s were sold on to GB Rail Freight as part of a broader fleet reshuffle. Further Class 60s found new life elsewhere, with March 2019 seeing DC Rail acquire 4 locomotives from DB Cargo, all of which had undergone refurbishment, with these additions forming the basis of a growing Class 60 fleet for DC Rail, which would go on to become the largest operator of the type in the country. Nevertheless, the overall trend has remained one of gradual decline, and by 2025, only a limited number of Class 60s remained in active service across the network, with DB Cargo retaining 14 operational locomotives, primarily used on bulk freight services such as steel and petroleum, while DC Rail has expanded its fleet to 19 working units, operating on construction and aggregates traffic, while GB Rail Freight fielded 13 locomotives. Beyond those in regular use, 3 locomotives have entered preservation: 60050, 60081, and 60086, providing a glimpse of potential future museum or heritage line operation, while by contrast, 60006 became the first of the class to be scrapped in January 2020, and the remainder of the class, amounting to approximately 50 locomotives, remain in long-term storage, where many have deteriorated to a point where their return to service would require a level of investment unlikely to be recouped through operational use, and it is generally accepted that the majority of the stored fleet is unlikely to ever work again. In summary, while the Class 60 promised many things with its exceptional power and sturdy design, the reliability of these purposeful-looking machines was ultimately the Achilles heel of what should have been a freight locomotive to put the likes of the Class 59 to shame. Instead, the failure of the Class 60 to perform as expected during those early years proved to be the incentive for EWS wishing to procure a modular fleet of diesel engines, and with that the Class 60 soon found themselves pushed out of place by the new American metal. Nevertheless, while their numbers have diminished, these locomotives, following overhaul and modification, have now proven themselves to be a success story as originally anticipated back in the late 1980s, and for hauling the heaviest freight trains in the country, there is little better in terms of traction that can truly match the power of the venerable Class 60.